next lesson, we're going to be taking a closer look at formulas and functions. We found out that a formula is an algebraic equation that relates two or more real-life quantities. Some of the common formulas are listed here that we discussed in class last time. We can certainly add to this list, but this is a good start. We're going to be solving one of these formulas for a particular variable. Let's look at the distance formula. Distance is equal to rate times time. Most of the situations or word problems might say, here's the rate, here's the time, how far are you going? But what if I knew how far I had to go and I knew the speed in which I was going to travel at, but I didn't know how long it was going to take me to get there? I'd be solving for time. Well, in this first problem, I'm asking you now to think about what if you know the distance and you know how long you have to get there, and you had to find out how fast you need to go. So you're looking for the rate. So in order to isolate the rate, I have to use one inverse operation. What will I do here? I'll take my formula, distance equals rate times time. If I'm solving for r, I need to isolate it with one inverse operation. The inverse of multiplication is division. That will cancel things out on the right, and I'm left with r is equal to the distance divided by the time. Again, we're using what we know about isolating a variable. In all the previous problems, we were solving for x. Now that we have more than one variable, we're doing the same process. It's just that we're eliminating one particular variable. Here is our formula for area of a triangle. The area of a triangle is base times height divided by 2. What if I needed to find the height? I'm going to start by, and again I'll write my formula over. I have to isolate h. So I'm going to highlight that in a different color. I'm going to isolate h. And so now I am going to first start by multiplying both sides by 2. I have 2 times the area is equal to base times height. Again, my goal is to isolate h, and I do that now by one more inverse operation. I'm going to divide both sides by the base, or b. I was solving for h, so height is equal to 2 times the area divided by the base. Volume, length times width times height. So I'm listening to what operations are being performed in order to accomplish finding the volume, but I want to find the width, so I'm going to undo the multiplication by division. I'll divide both sides by the length and the height, and I'll get the width is equal to volume divided by length times height. I hope you're starting to see how this all works. Here we have the simple interest formula. Interest is money that you either earn or owe based on the amount of money, a rate, and a time. So principal is the money, rate is a percent, and time is in years. What if I was investing money at a rate of 3%, and I know how much interest I was accruing, and I need to know how much time it's going to take to get that. So we'll take this formula, and since principal times rate times time is all multiplication, I will divide by the principal and the rate. Whatever I do on the left, I do on the right. Isolating my variable here, I get the time is equal to interest divided by principal and rate. Now I want to move on to the function form of an equation. Many times when we look at an equation in two variables, for example, 2x plus 3y equals 12, that's in what we call standard form. We want to rewrite this in function form, which you may know as slope-intercept y is equal to mx plus b. So again, my goal is to isolate a variable. Anytime you isolate one variable on one side of an equation, it's in a function form. In particular, for slope-intercept, we want to isolate y. Always read your directions carefully. Once in a while, someone might ask you to solve for x instead of y, but for the majority of our problems, we'll be solving for y. So I see I have 2x added onto 3y, so the inverse will be to subtract. If I subtract 2x on the left, I do that on the right. Property of equality. I have 3y is equal to a negative 2x plus 12. Notice the positioning of that transformation. I am moving that 2x in front of the constant so that it's in y is equal to mx plus b, or function form. Not done yet because I haven't isolated my y. I'm going to divide all terms by 3. So I get y is equal to a negative 2/3 times x plus 4. We're going to be doing a whole series of these because this is going to become very important in our next 2 chapters. We can look at some more formulas, but for now I'd like to look a little bit more at this function form for maybe 1 or 2 more problems. My goal once again is to isolate y. I'll do that first here by subtracting 2x on both sides. Cancels on the left. I'm left this time with a negative y. I didn't want to solve for negative y, so I'm either going to multiply or divide by negative 1, which simply just changes the signs of every single term. And now I have my function form. One last problem for this practice set today. I'm going to add, inverse operation, add 4x. When it cancels on the left, my y is isolated. That was my objective. Now I have 4x plus 7. Again, it's very important that you get in the good habit of writing that x term in front of the constant so that we're getting good practice for putting in something in slope-intercept form. We'll do some more examples in class, and we'll see how well you're progressing with this.